So far we've learned scattered graph or scattered plot and how to interpret it and what are the features of it and all. The last part of this is about prediction. Okay. One of the purposes of a relationship investigation is to determine if the data will be appropriate for modeling purposes. So that means, can we use it to make predictions? So we focus here only on linear models and we will use NZgrapher to fit the model. We will draw a line called the line of best fit and make a prediction based on this line. So if we don't have a line, it's very hard to make a prediction. So this red line here is kind of like an average of all the scattered points. So let's go to the NZgrapher. So let's open NZgrapher. Just go to any browser and then type in NZgrapher. And you will say this on top and you just go in, okay? NZgrapher has a lot of data set that is preloaded for practice purposes. So now let us choose cars. It can be any one of those. Oh, but those with TS is for time series, is not suited for scatter plots. So let's choose anyone from those without TS. Okay, so I'll choose cars and choose scatter plot, scatter graph, and you choose variables. So for variable 1, which will be on x-axis, I want to choose something explanatory. Independent variable. So I would choose maybe engine size. Okay. And then engine size should determine, should have some influence on the price. Not all, but let me just put the price there. So I can see a very moderate or weak, I guess, positive linear relationship here. So what I will do, the first thing I will do is put a mean dot. This is the mean of the average of the engine size and the price. This dot represent that. And then you scroll down and take this add cost line where you can hand draw in a way the line of best fit. Okay, you can kind of maybe something like this, I guess. And then you can do the show equation, and that equation would be shown here. So this is how you draw the line of best fit by hand. But what you can actually do is, look at this, there's a regression line box there. So you can pick this, and then the regression line, which is the line of best fit, will be automatically generated. So you actually don't need to hand draw the thing. We did it only because we wanted to practice hand drawing. So you can always use this regression line, okay? Okay, so we got this graph that shows the engine size and price relationship with the line of best fit and the equation, okay? So that's the equation there. If we enlarge it, it says price equals to 5.4957 times engine size plus 6.3117. What that means is, this is the equation. It's like if you think of it as price as a y and engine size as an x. It's like saying algebraically y equals to 5.4957 times x plus 6.3117. If you recall what you learned in algebra, you can express a line on a graph using a function. For example, like the red line on the right-hand side says y equals to 1/2 x plus 2, right? And with this equation or function, if you substitute a value to x, you can get the value of y, okay? So same here for the engine size and price. If you have an engine size, you can kind of estimate or predict the price. For example, if the engine size is 4 liter, then you can put that into engine size and then get the value of the price, which is 28.2945. It doesn't say the unit here, but I would assume it's $1,000. So $28,000 approximately. Of course, a car price is not solely determined by the engine size, not at all. There are many, many other factors that affects car price, but this is just one of the ways to predict the price using the engine size. Another way is on the previous slide, we used the equation, but we can also use the graph itself to kind of manually predict the price. First of all, if you know that engine size is 4 liter, then you draw a line from 4 liter all the way up until it hits the line of best fit, and then extend it horizontally to the y-axis where it shows price. And then you can see it's about 26.7-ish. Okay, it's maybe the way I drew the line is not that accurate, but it's pretty close to what you get from the equation. Right.